In our previous analysis for uniform circular motion, we derived the following quantities. So the speed was equal to the radius of the circle by the magnitude of the angular velocity, and that's tangential to the path. And we had the velocity being equal to the speed in the tangential or theta direction. So at time t, we have a tangential and radial direction, and at time t plus delta t, we had a tangential and radial direction. Now in the case of non-uniform circular motion, the speed or the magnitude of the velocity is not constant. So when we differentiate this expression, we use the product rule and we obtain the following equation for the acceleration. And we derived this previously for the case of uniform circular motion. So this was equal to minus omega in the radial direction. And if we're using this expression, we can write this expression as follows. So therefore, if this is the velocity at time t, and this here is our velocity at time t plus delta t, so therefore by vector addition, this here is equal to the change in velocity. And note that the acceleration, being the first derivative of velocity with respect to time, acts in the same direction as this vector dv. And therefore the acceleration has a component that points towards the center of the circle, which is this component, and it also has this component which points in a tangential direction. So therefore the tangential component changes the speed, and the normal component changes the direction of the particle.